Hi everyone, welcome to Science Tech Day. So today I want to take you through on how resistors work, the calculation of the color band, how to calculate the band, and how to know the value of your resistor without using a multimeter. So all that I'm going to take you through today. But before I go on, I want to tell you that a resistor always opposes the flow of electricity. So you need to understand how these resistors work. So before I leave this place very far, I have to first of all, before I take you to color bands and how to calculate the color bands, I have to first of all teach you on how these resistors work and what is a resistor. But remember, a resistor a resistor always opposes the flow of electricity. That's why in most cases, for example, when you connect your bulb direct on a battery, a bulb can be blown off. Why do I say that a bulb can blow off? A bulb is made of a wire inside it, and when you connect it with a battery direct, the wire which is in the bulb, it's going to be blown off or it will break. Then after it breaking, the bulb will no longer be working. But for it to reduce or to reduce on this risk, you have to use the resistor. But now this resistor, what does it do? Resistor always reduce or opposes the flow of electricity. It only allows a certain amount of electricity to go through. So you have to know that a resistor opposes the flow of electricity. So you have to know this very well, that a resistor always opposes the flow of electricity. But now in a resistor, you have to know that a resistor, we have different types of resistor. We have the variable resistors, then we also have the fixed resistors, and on the other hand, we can also talk about the metal film resistors, then we also have the carbon film resistors, then we also have the carbon composition resistors. So all those resistors, you have to know how they are made up and how they do work. But now when I go on metal film resistors, that is, let me say, a metal film resistor. So now this metal film resistor, this is a resistor which is made up of a metal film, then it's also, and having a ceramic core, then it's also insulated with an insulated, then it's covered, or it's cased using an insulated material. That's how it's being made. So they use metal, then with a ceramic core, then they case it using an insulated material. Then we also have a carbon film resistor. So how does this made? Now a carbon film resistor, you have to understand that a carbon film resistor, this one is made up of a carbon film. Then this carbon film is this is made up of a carbon film with a ceramic core. Then it's also cased with an insulated material. Then we also have a carbon composition resistor. Now it's made out of a carbon composition, then with a ceramic core. Then it's also cased with an insulated material. But you need to understand that how do these resistors measured? Resistors are always measured in ohms. So you have to understand that resistors are being measured in ohms. But as I've told you before, that we have different types of resistors. We have the other one which has colors. We have the other one which only has numbers. So you need to understand, whereby we have the potentiometer, that falls under variable resistors. Then we also have we have different types of resistors. So we have to talk about that all today. But now, before I leave this place, I've told you that today I'm going to teach you on the value of the colors of the resistors. For example, when we come here, you need to understand that a resistor, the numbering of resistor, you have to understand the coloring of the resistors. So whereby we have the colors, then we have the bands, Then you also have to know that we have the multiplier. Then we also have the tolerance. But now you have to know that the tolerance is spaced from the other colors. That one which you see, which is having a space from the other colors, that's the tolerance. So you need to understand that. So I'm going to draw for you a table showing you the color of a resistor, the coloring of the color bands of the resistor. So let me first of all draw for you the table before we go on from how to read these colors very well, which is going to teach you on how, or which is going to explain to you on how to read these colors, because now it will be very hard for you to read it, to have it. You can also have it from mind, or you cannot have it. But now, for you to understand or to read these colors very well, you should have a guidance of a colors, these color bands, a color band table. So let me first of all draw for you here the color band table. Then after that I will take you through on different questions on how you can read the values of the value of a resistor, or how you can know the coloring of this resistor and what does it mean. And this will help you to really understand the capacity of a resistor and how these resistors work. So let me begin with drawing a table. So we begin, we draw. First of all, we can draw this first one. This is our first line. This is our first line. Then we draw also this. After drawing that, we write here colors. This is our colors, our color. Then, after that, we also have here, this will be our first band. This will be our first band. This will be our first band. Our first band color. But now, you need to have this on your head, on how to read these colors very well. In that you even if they wake you from anywhere, when you are still on your bed, so if someone tells you that, now this color, what does it mean? How can I know that this brown is in number 2? So you have to know this, you have to cram this on your head, or you have to understand it as you. Because now if we are to join electronic department, you need to understand that these colors is very important, because you can't read these resistors without knowing how to use these colors. And mostly nowadays, most of the resistors people use nowadays is this one which has colors. So you need to know this very well. So the first one here, we are going to begin with black. So we write here, this is black. Then the second is going to be brown. Then the third, we are going to have red. Then the fourth one, we are going to have orange. Then here in this box, we are having yellow. Then on this one, we have what we call green. We have here green color. Then after green, we have what we call blue, the color called the blue. Then we have violet. We have here, that is violet. Then here we have gray. Then here we have white. Then we have here gold. We have gold. Then the last one is silver. The last one is silver. So here we have black, we have brown, we have red, we have orange, we have yellow, we have green, we have blue, violet, gray, white, gold, and silver. So the first one is going to be 0. The second one is 1. This one is 2. That's red. Orange is 3. Then we have yellow. That is, it will be 4. Then we have green. That will be our 5. Then we have blue. That will be our 6. Then we have violet, that will be our 7. Then we have gray, that will be our 8. Then we have white, that will be our 9. So we end in 9. So this last box is just there empty. So you just have to leave them empty. That's gold and silver. So for them, they are just empty. So you have to know that with the first one, that's black, is 0. Then we have brown, that will be 1. Then we have red, it's 2. We have orange, it's 3. We have yellow, which is 4. We have green, which is 5. We have blue, which is 6. Then we have violet, which is 7. Then we have gray, which is 8. Then we have white, which is 9. Then we have gold. Gold is empty. Then we also have silver. You just have to leave an empty space. Then we go to the second band. This is our second band here. You have to where we are going to go is what has brought us here. But I understand and I know that all of you who are there, who are watching me from different parts of the country, I do understand that you are going to learn this within a short time. Before me even completing this, I do understand that you are going to learn each and everything from this. And I do welcome all the comments I do welcome all the questions in our comment section. So for any question, you should send us, or you should type your question on our comment section, and we shall answer you directly. So you should have a look on this. As I've told you, I understand maybe you've already taken the picture of it. You have a look on it, how these things are being arranged. And I told you before that in this table, gold and silver, in first band, second band, and third band, they are not there. But now they come in here in the multiplier, whereby we have our gold, whereby we have our gold as 0.1 ohms. Then we have silver as 0.01 ohms. So it's here in multiplier. But now in multiplier, you need to understand that gray and white is not there. It's just empty. That's why I have left here an empty place. Then we also have this. You have to understand that in tolerance, we don't have black. So that's why I've left here an empty box. Then we also have here, we have red, that is plus negative 1%. Then we also have this one, which is this one is brown, which is having plus 1%. Then we have red, which is having plus negative 2%. But you need to understand this, that tolerance is in percentage. You need to understand that. So, and you need to take note of this, that tolerance is in percentage. You need to understand this. But now you also need to understand, we are going to take you through on how you can convert these things here to kilo ohms. This one you can convert it to kilo ohms. Then you can also convert, because now we can't use these zeros, many zeros, when we are representing the capacity of our resistors. So you need to understand this very well. So let me wrap this. Then after, I take you through on how these resistors work and the capacities of these resistors and how to control and how to actually deal and to read this resistor without you using a multimeter. But secondly, you can also use a multimeter to read this. But now this one is more important, because now this can help you, and you can even understand you can know the lower and the upper bands of these resistors. What do I mean? This is the capacity between which this is the value, this is the range in which this resistor can operate, or the amount of current which this resistor can allow to go through. That's what when I talk of the upper and the lower band, that is the range in which a resistor can contain a certain amount of power to go through. But remember, you have to understand that these resistors can also be blown off. When the power which is going through is higher, you have to know that these resistors can also be blown off. But what I not yet told you, that the bigger the resistor, the larger the amount of current going through, or the larger the capacity of that resistor. So the smaller the resistor, the smaller or the lower the capacity of that resistor. So you need to know and you need to understand this very well. So let me wrap this, and as I'm going to take you through the calculation part of it. But now you need to have your calculator with you there, such that I take you through this and you get to understand it very well. But you need to have all this on your head as we are going through this. Let's assume that this first one is brown. Let us assume this first one is brown. Then the second one is black. Then the third one here is also black. So I've said this first one is brown. So from the first band, so this is going to be our first band, our color, and it will be the first band. So from the other side, the first band, brown is having what? Brown is 1. Then in the second band, black is having what? Black is having 0. That's -1%. But remember it very well, I told you from the beginning, the other side, that you need to understand that tolerance is in percentage. So let's go direct to how to determine these colors very well. I've already written it here. That here we are having brown. So you just bring here your number 1. Have you heard? Are you getting me very well? So here we are having black, which is 0. So we only here bring our 0. Are you getting me, everyone? So here we are having in the third band, we have color black. So it's having a value, it's in a value of 0. So here we are going to have 0. Then after that, in a multiplier, we are having orange, which is having 1,000. So what do I mean here in multiplier? So we are going to multiply this 100 times this 1,000, which we got from this 1,000. I'm talking of this 1,000 here, the multiplier. What do I mean? A multiplier means you multiply with the other value you have. So we multiply by 100 by 1,000. That is orange. And then this one, you can maybe just bring it. You can bring this. Then you also write this and 1%. Or I will also teach you on how to get the upper and the lower bands also after that. So let me first take you through this, and you get to know it very well. Then after, I'll teach you on how, I'll take you through on how to calculate the lower and the upper band also. So here, when you multiply this times this, how many do you get? So when you multiply 100 times 1,000, so we are going to get 100,000 ohms. But now, these zeros, you can't have this too much zeros. You have to reduce these zeros at least. That's why I told you that you need to understand how to convert also this to convert the units of these resistors. For example, because now these zeros are too much, so we need to reduce it at least. So how do I reduce it? So we are going to begin here that 1 ohms. So we want to reduce this such that we either put it, we either make it be a mega ohms, or it will be a kilo ohms. So we don't know. So let's begin it right now. So 1 ohms, let us assume 1 ohms is equal to 1,000 is equal to 1 ohms is equal to 1,000. Then let us assume x. What about x here? X will be 100,000 ohms. So we need to convert this. Then here you cross multiply. Are you getting me? Then after cross multiplying, this one becomes x. This one is x. This becomes 1,000 x 1000 x is equal to 1000 100,000 ohms. Then after this, you need to divide both sides for you to get the figures very well. Divide this both sides, because now we need to reduce this. We need to convert it to kilo ohms. In that for us, we can get it at least some figure which doesn't have too much zeros. These zeros are too much, so we need to reduce it. So we need to change this to either kilo ohms or mega ohms. So this one, you divide both sides by 100, by 1000. Then you divide here also by 1000. This zeros goes away. Then this one, then also this 3 zeros also goes away. So we remain x is equal to 100 kilo ohms. So there we've reduced our figure.